Hello, my dear students. I once again welcome you all to this current lecture. In the last lecture, we completed the chapter Electrolytic Conductance. Now, after that, in the current lecture, we are going to start the next chapter from this syllabus, that is the phase rule. It is the chapter number 4, phase rule. Now, as far as this phase rule is considered, we have to consider the different aspects regarding the different type of the systems. We have to study the effects of the various experimental factors on these particular systems, its composition, and the different examples of the systems. So first of all, we have to consider some introductory part regarding this chapter. So we know very well know a temperature, that is transition temperature. One important temperature is there, that is the transition temperature. Now, as far as this transition temperature is considered, this temperature gives us an idea regarding the conversion of one state of a substance into another state of a substance, or we can say here, whenever the two different states of a substance is present, then a temperature is important, that is our transition temperature. Suppose we consider a melting point of a substance, that is a solid phase of a substance is in equilibrium with the liquid phase or liquid state of a substance. So this is a equilibrium between the two states or two phases of a substance. Its solid phase is in equilibrium with a liquid phase. So we can say that whenever such a type of the equilibrium is there between the two phases of a substance, we call it commonly as a its melting point. We commonly call it as its melting point of a substance. So at the melting point of a substance, there is a equilibrium between the solid phase of a substance to that of its liquid phase. So at this such a type of the equilibrium, there is one temperature, and that temperature is nothing but our transition temperature. A temperature is important at such a type of the situation, that is called as the transition temperature. So this transition temperature is important whenever we see such a type of the equilibrium between the two different phases of a substance. Now, as far as this transition temperature is considered, in this case there is an equilibrium. There is an equilibrium between these two phases of a substance. So whenever we change the external conditions, whenever we change the external conditions of such a type of the equilibrium, these external conditions, that is nothing but the temperature, or it may be the pressure. When we change such a type of the external conditions of such a type of the systems, then what happens? There is a variation in transition temperature, and indirectly we can say that whenever we change such a type of the experimental conditions, that is external conditions, automatically there is a shifting in this equilibrium constant. A state of equilibrium can be takes place. So whenever such a type of the variations we want to study, so for this purpose we have to take into consideration two different equations. So first important equation is the Clapeyron equations. The Clapeyron equation is there. So according to the Clapeyron equation, we can study here the variation of transition temperature. This is variation of transition temperature with respect to change in pressure. with respect to external pressure, with respect to the external pressure. So whenever we want to study such a type of the variation of this transition temperature with external pressure, we have to take the help of Clapeyron equation. Next to this Clapeyron equation, a second equation, important equation is there, that is Clausius, Clapeyron equation, that is the Clausius Clapeyron equation. It gives us an idea regarding the variation of this variation of transition temperature with respect to temperature. So these are the two different equations helpful for studying the variation of transition temperature with respect to either external pressure or with respect to the temperature. So we can say that whenever we want to study the equilibrium between the different phases of a substances, then how these different phases get affected with the application of temperature and pressure. So this type of the study can be done with the help of one important rule, and that rule is called as the phase rule. That rule is called as the phase rule, and that is nothing but the name of our chapter, that is a phase rule. So this phase rule is very important as far as the study of the equilibrium between the different phases of a substance is considered and their variation with that of the conditions like temperature and pressure. So this phase rule was derived on the basis of thermodynamic principle by the American scientist, that is Jose Willard Gibbs. That is Jose Willard Gibbs. So the scientists propose this phase rule depending upon the thermodynamic principle. So the study of this particular phase rule is very important as far as the different type of the systems are considered in order to study their composition as well as the effects of the external parameters. So before starting this chapter phase rule, first of all we are going to study some important concepts from this chapter which are very useful for the further study. So some important terminology or some important definitions are there. So the first important definitions from the chapter is called as the system. So this is one important word for this phase rule we come across a number of times. So the question arises, what is meant by system? So a system of a particular substance, whenever a particular substance is present, how to define this system? So a system in connection with the phase rule, a system in connection with the phase rule is defined is defined as a substance a substance or a mixture of substances which is isolated which is isolated in some way from other substances from other substances. So this is the definition for the system. So as far as this system is considered, a system in connection with the phase rule, when we take the help of phase rule, then how to define the system is defined as a substance. So a system may be a substance, or sometimes it may be a mixture of the substances. So these are the two different conditions for a system. It may be a single substance, or it may be a mixture of substances which is isolated, which must be isolated in by the some suitable mean from the other substances. Then such a type of part is called as the system. Now as far as the systems are considered, there are a number of different systems is there. So if we want to write the different names of the system, some important systems are a water system. Water system is an important system. Water system is there. We may take here sulfur system. Sulfur system is there. We may take here silver lead system. So these are some simple examples of the system. We may take here water system, sulfur, or we may take here a combination of silver and lead system. So this is the first important terms from the chapter, that is a system. Now the second important concepts from the chapter is called as the phase. Second important concept is there, that is a phase. That is also important point which we use many times in this chapter, that is a phase. Now what is mean by this phase? So as far as the meaning of this phase is considered, it is a Greek word. It is a Greek word which means appearance. Which means appearance. So something which get appeared, so that in generally called as a phase. Now how to define this particular phase? So it is defined as a homogeneous part. It is defined as a homogeneous part of a system. It is a homogeneous part of a system that is physically distinct. That is physically distinct and mechanically and mechanically separable from other parts of the system, from other parts of the system. So the phase is nothing but it must be a homogeneous part of a system as far as a system is considered. So a homogeneous part of the system, that part must be physically distinct. Means what? It has its own existence. It must be physically distinct as well as it must be mechanically separable from other parts of the system. So when such a type of the homogeneous part is there, then that homogeneous part is called as the phase of the system. Now this phase of the system, as we know that it must be physically distinct as well as mechanically separable. Now as far as these two different factors is considered, what is by physically distinct? It means that it must have its own identity, it must have its own state. So if we take the different systems, different phases in a particular system, each phase must have its physical appearance. The second important thing is that mechanically separable means what? If we want to separate different phases from a system, it must be mechanically separable. So this type of part is called as the phase. Now as far as the example of this phase is considered, so for this purpose, if we consider example of water system, if we consider the example of water system, then what happens? We know very well that this water system is exist in three different phases. That is, in a water system, three different phases are there. What are that phases? First is called the ice. This ice is in equilibrium with that of the water. This water is in equilibrium with that of the water vapor. With that of the water vapor. So we can say that if we consider the water system, this water system have the three different type of the phases. It is a ice, second is called as a water phase, and third is called as the water vapor as a phase. So what is this? This ice is nothing but the solid phase or solid state is there. Water stands for its liquid phase or liquid state, and the water vapor stands for its gaseous state or gaseous phase. So these type of the parts are called as a physically distinct. We know that all these three different parts of a water is a physically distinct, as well as it is a mechanically separable. So this is called as the important concept called as the phase of the particular system. Now if we consider some specific applications of the particular phases, if we consider the particular application examples of these particular phases, or how to decide the number of phases in a particular system. So for this purpose we have to take the help of some important rules. So the first important rule for this counting of the number of phases in a particular system, so the first important rule for this purpose is, the first important rule is there for this decidation of this particular number of systems. Every solid in the system, every solid in a system constitutes a separate phase. Means if we take a mixture of different solids, so each solid in a system is considered to be a separate phase. For example, if we take the example of calcium carbonate, it is in a solid state. So it is in equilibrium with that of calcium oxide. It is in a solid state, as well as second is a CO2 in a gaseous phase or gaseous state. So what happens if we want to count the phases of this particular system? Then two solids is there. One is the calcium carbonate in a solid state, and the second is called as the calcium oxide in a solid state. So both these solids is considered to be as a separate phase. So this is a first phase, this is the second phase, as well as the third compound is there, that is a CO2. It is a gaseous in state, so it is also to be considered as a separate phase. So three phases is there for this particular system. So this is a rule number first. Now second important rule is there for this phase counting, that is gases are completely miscible. Gases are completely miscible. Therefore, whenever we want to count the number of phases, then what happens? Mixture of gases are considered to be a single phase. It must be a single phase. Whenever we consider a different gases as a mixture, then we have to consider it as a single phase. And the third important rule is there. So whenever we consider, suppose a liquid, for example, if we consider here a mixture, we take it directly a mixture, that is a mixture of mercury, that is Hg in the liquid state, plus we take here water, liquid state, plus CCl4, again in a liquid state. So it is a mixture. So it is a mixture which consists of the three different liquids, three different liquid phases there. One is a mercury in a liquid state, second is a water in a liquid state, and third is a carbon tetrachloride in a liquid state. So it is a one mixture. So whenever we want to count the different phases of this particular type of a mixture, then what happens, each liquid each liquid is considered to be as a separate phase. So for Hg it is a first phase, for this water it is considered to be as a second phase, and for this CCl4 it is to be considered as a third phase, and the fourth phase is there. The fourth phase is there. Now what is that fourth phase? So this fourth phase is called as the vapor. The fourth phase is called as its vapor. So you can say that whenever such a type of the different liquids are there, that liquids are considered to be as a separate phase, and a vapor state we have to consider here. So as far as this mixture is considered, it has the four different phases. So this is a next important concept called as the phase of a particular system. Now after studying this phase, the next important concept from this chapter is called as the component. It is a component that is represented by the word C. This is a component. Now what is mean by the component? So this component is defined as the minimum number of, it is defined as the minimum number of molecular species, the minimum number of molecular species in terms of in terms of in terms of which the composition of in terms of which the composition of all the phases, composition of all the phases may be quantitatively expressed, may be quantitatively expressed. So this component is defined as the minimum number of molecular species in terms of which the composition of all the phases may be quantitatively expressed. So that is called as the component of a system. Now if we consider again our regular water system, if we consider this again here, a water system, so we know very well that this water system has the three different type of the phases. Again this ice in equilibrium with the water, and this water is in equilibrium with the vapors, vapors. So there are three different phases is there. Now what is the meaning of this component? So as far as these three different phases of the water is considered, then the question arises how to express completely these particular three phases of a water. Then what is the molecular species which is important in order to express completely three phases of this particular water? So the simple answer to this is that if we want to express these three phases in a one of the molecular species, so that is nothing but our H2O. That is a H2O. We can say it as a water. So in these three phases of water system, that is ice, water, and vapor, what is present, what chemical species is present, and that is nothing but the water. So we can say that this water system is called as the one component system. This water system is called as the one component system. Why it is a one component system? Because in order to express completely this particular system, one important molecular species is there, a chemical species is there, that is called as a water. By using this H2O, we can express all the phases of this system completely. So it is called as the one component system. Now if I take the second example for understanding this component, consider here the second example as calcium carbonate, calcium carbonate in solid state, it is in equilibrium with that of calcium oxide in solid state plus carbon dioxide in a gaseous state. Now, if we want to find out a molecular species which is required in order to express this particular system, so for this purpose, if we take a combination of, if we take the two components like, if we take components like either calcium carbonate and calcium oxide, or we may take here a mixture or two components as calcium oxide and carbon dioxide. So if we take such a type of the pairs, by choosing such a type of the pairs of the molecular species or chemical species, we may express the three different phases of this particular system. That is, this is the first solid system, this second system, and this is gas as a third system. So by taking such a type of the pairs of the chemical species, we may express such a type of the phases quantitatively for this given system. That's why we can say that this particular system is called as the two component system. It is called as two component system. Why it is a two component? Because two chemical species or molecular species we take into consideration for expressing completely all the phases present in this particular system. So this is example of two component system, and first is example of the one component system. So this is called as the important concept, component of a particular system. So in the current lecture we studied the we started the new chapter that is called as the phase rule. In this phase rule, at the initial part we studied the simple introduction, in which we studied about what is my transition temperature, how to study the change in transition temperature by using the two different equations, Clapeyron equation and Clausius-Clapeyron equation. Then what is by this phase rule, what is the applications of this particular phase rule. After that we studied the three important concepts in order to study this phase rule. That is nothing but the first concept is the system, what is by this system. Second important concept is what is by this phase, and at the last we studied here what is mean by component of a system. So with this we stop here. The remaining points from the chapter we will take in a next lecture. So with that I stop here. Thank you so much.